So just want to briefly go over a special case of NIRSpec IFU observations of giant planet satellites, right? This is probably something that people are interested in, right? They've been executed many times before in previous cycles, but there is an issue here with the fact that the host planets are usually very bright. And this is specifically a problem for Jupiter and Saturn. So Ian was showing where the IFU falls with respect to the entire NIRSpec footprint. So the IFU is very small, 3 by 3 arc seconds, and it falls in between these 4 micro shutter arrays. So those are used for multi-object spectroscopy, but they share the same detector as the IFU. So if you place a satellite, you can imagine placing a satellite in the IFU, and depending on the time of year that you're observing, you end up with the giant planet falling on the microshutters. So the attenuation of a fully closed microshutter array is a factor of 10,000. But for an object as bright as Jupiter, you still get significant contamination of Jupiter's spectrum onto the spectrum of the satellite you're observing. And also, there are defects in the microshutter arrays. There are some microshutters that are always open. There's some that are always closed. So you are going to get contamination directly through the always open shutters on top of the attenuation, right? So how do you avoid this contamination from affecting your observations? First you need to consider the time of year, right? And what hemisphere, for instance, of your target you're observing. Let's say that you're observing Io again. We'll say Io. You're looking at the leading hemisphere of Io because it's tidally locked. You want to make sure that you're observing in such a way that Jupiter is off of the MSA field of view, right, and as far away as possible. And given the time of year and which field of regard you're looking in, there'll be different cases that work in both situations, right? So you can imagine in this case, if Io is here and you have Jupiter off to the west, that works in this situation, but it doesn't work in this situation. So how do you determine what you need to do there? The general rule of thumb, and here's just a different picture showing the different MSA fields of view in the IFU with a cartoon here of Saturn showing greatest western elongation, you're looking at the trailing hemisphere. Greatest eastern elongation, you're looking at the leading hemisphere. And what you want to do is observe satellites at eastern elongation, or the leading hemisphere, when you're in the trailing field of regard. And alternately, you want to look at trailing hemisphere when you're in the leading field of regard. So basically the opposite of which hemisphere you're looking at, for instance. So to do that, you have to specify both an orbital longitude or central meridian longitude constraint, right, to make sure that you're getting the hemisphere you want, assuming that that's part of your science case. And then you want to specify between timing requirements to ensure that you're getting the correct field of regard. There's a caveat here if you're using JPL horizons to determine if you're in the leading or trailing field of regard. Horizons uses a different convention for leading and trailing. So the option 23 there, Sun Observer Target Elong angle, it provides a leading trailing flag, but that's the opposite of which is the opposite name for the JWST field of regard. So it can get very confusing very quickly. I hope that this information, providing it in a recorded session, helps people understand that. There's also documentation discussing a lot of the same stuff too. There's also, this is a more complicated problem if you're looking at sub or anti Planet hemispheres, right? This is easy enough to do to specify for leading and trailing, but sub and anti, it's harder to specify. You really have to really visualize where the target is at a given point in time. And largely, this is not an issue for regular satellites. Right, they're far enough away from Jupiter, Saturn, whatever, that you don't have to worry about contamination of those spectra by the giant planets themselves. This is mostly for the regular satellites, right? And as I said, mostly for Jupiter and Saturn. Uranus and Neptune are not as much of an issue. They're not as bright, but something that you still might want to consider.